Picture a forest. Dense, ancient, humid. The trees are enormous, oaks and laurels the width of a car, their canopies so thick the ground below them is in permanent twilight. The air smells like something alive. And moving through the branches above you, watching you with amber eyes from the shadows, a primate. Not a human. Not anything you have a word for. Something between. Something that was here millions of years before your species drew its first breath on this planet. Something that looked just familiar enough to be deeply, fundamentally unsettling. This forest is not in Africa. It is not in Asia. It is in what is now Spain. It is in what is now Germany. It is in what is now France and Greece and Turkey and the British Isles. And the primate watching you from the branches has been here for 12 million years. You have been here for 300,000. The mathematics of that comparison should tell you something about who the original occupant of this landscape actually was. Here is what nobody tells you about human prehistory. For tens of millions of years before the first human ancestor stood upright on the African savanna, Europe was a primate continent. Not an outpost. Not an occasional visitor's route. A full, rich, extraordinarily diverse primate ecosystem, one that produced animals of remarkable complexity, surprising intelligence, and in some cases, anatomical features that researchers are still arguing about today because of how unsettlingly close to human they appear. And then, somewhere between 5 and 7 million years ago, Europe's primate dynasty ended. And the reasons it ended, and what the animals that ended it looked like, and the specific detail of what exactly was walking through that ancient European forest watching you with those amber eyes, that is the story we are telling today. We need to go back approximately 34 million years to understand where European primates came from. Because they did not originate in Europe. The first primates arrived in Europe from Africa, crossing what was then a much shallower and more fragmented version of the ancient Tethys Sea, a warm body of water that sat between Africa and Europe before the Mediterranean as we know it existed. These early primates were small, relatively unspecialized, and arrived in a Europe that was warmer and more forested than it is today, more similar in some respects to the tropical and subtropical forests of modern Central Africa than to the continent you know now. For the next 15 million years, through what geologists call the Oligocene and into the Miocene epoch, these primate populations in Europe diversified, adapted, and in some lineages, grew considerably larger and more complex. And it is in the Miocene, specifically the Middle Miocene, beginning approximately 14 million years ago, that the story becomes genuinely extraordinary. Because this is when the apes arrived in Europe. And this is when Europe, for a window of approximately 8 to 9 million years, became one of the most species-rich great ape environments on the planet. The Miocene apes of Europe. This is the group of animals your video is actually about, and they deserve to be introduced with the weight they are owed. At least 14 distinct genera of apes have been identified in European fossil sites from the Miocene period. 14 genera, not 14 species, 14 entire genera, spread across a fossil record that extends from Spain in the west to Turkey and Georgia in the east, from Germany in the north to Greece in the south. The diversity of European apes in the Miocene exceeded the diversity of apes alive on the entire planet today. That fact should stop you. The entire planet today has 4 genera of great apes. Europe alone, in the Miocene, had 14. The most famous of the European Miocene apes, and the one with the most direct relevance to the human lineage debate, is Dryopithecus. The name means oak ape, named for the ancient oak forests in which it lived across Western and Central Europe. Dryopithecus was a large ape, estimated body mass between 25 and 50 kilograms depending on the species and the individual, placing it broadly in the size range of modern chimpanzees and bonobos. It moved through the forest canopy with a combination of arm-swinging locomotion, brachiation, and careful four-limbed movement along large branches, similar in its general pattern to modern great apes. Its face, in the reconstructions that paleontologists have produced from fossil material, is strikingly modern in some respects, the brow ridge less pronounced than in the African apes of similar periods, the forehead slightly more vertical, the eyes forward-facing in a broad, relatively flat face. Looking at a reconstruction of Dryopithecus is an experience with a specific psychological quality, the quality of looking at something that should be familiar and finding it almost familiar, which is a different and more disturbing experience than either recognition or complete strangeness. But Dryopithecus is not the animal at the center of the most significant ongoing scientific debate about European Miocene apes. That position belongs to Danuvius guggenmoos. An ape discovered in Bavaria, Germany, in 2019, so recently that the implications are still being processed by the scientific community. Danuvius lived approximately 11.6 million years ago and had a set of anatomical features that produced, when the research was published in the journal Nature, one of the most intensely argued paleontological debates of the last decade. Here is the specific issue with Danuvius. The limb bones, particularly the femur, the shin bone, and the foot bones, show a configuration that researchers have described as consistent with an upright posture and bipedal-capable locomotion. Not identical to human bipedalism, but anatomically closer to the human upright walking pattern than to the knuckle-walking pattern of modern chimpanzees and gorillas. The knee joint is extended rather than partially flexed. The big toe shows weight-bearing characteristics. The lower back vertebrae suggest a lumbar curve, the curve that allows the human spine to absorb the shock of upright walking, rather than the straighter back of a knuckle walker. If this interpretation is correct, and it is contested, with respected researchers on both sides of the argument, then Danuvius was practicing a form of upright locomotion in Europe 11.5 million years ago. More than 8 million years before the earliest undisputed human ancestor walked upright in Africa. More than 11 million years before the first Homo sapiens drew breath. The contested interpretation of Danuvius matters for a reason that goes beyond academic taxonomy. It challenges the most fundamental assumption of the human origin story, that upright walking evolved in Africa, in response to the expansion of the African savanna, as the forests that our ancestors lived in retreated. If an ape in Bavaria was walking upright 11.5 million years ago, in a European forest, not on an African savanna, before any identifiable human ancestor existed, then the story of why we walk the way we walk needs to be fundamentally reconsidered. Danuvius's discoverer, Madeleine Bohm of the University of Tübingen, has proposed what she calls the European hypothesis, the idea that the anatomical foundations of human bipedalism did not originate in Africa at all, but in the tree-walking apes of Miocene Europe. That a specific form of upright, two-limbed movement evolved in the European forest canopy as an adaptation to moving along large branches, and that when populations of these upright-capable European apes eventually migrated back to Africa, between 8 and 9 million years ago, they carried the anatomical pre-adaptation for ground-level bipedalism with them. The African savanna did not create upright walking. It merely extended a capability that had already been developing for millions of years in the forests of Europe. In the forest above what is now Bavaria. This is not the scientific consensus. This is a hypothesis, actively debated, with serious and credentialed opposition. But it is a hypothesis supported by fossil evidence. Physical bones. Specific measurable anatomical features. And the detail that makes it genuinely difficult to dismiss is this. There are no African fossils from the period between 12 and 7 million years ago that demonstrate the anatomical precursors to bipedalism. The African fossil record from that critical window is, to put it precisely, almost completely empty. We do not have African ape fossils from the period when bipedalism was supposedly evolving in Africa. What we do have are European ape fossils from that same period showing anatomical features consistent with upright posture. The absence is the argument. The other European Miocene ape that demands attention in this story is Auranopithecus. The name means sky ape, or heavenly ape, from the Greek. Found primarily in Greece and Turkey in deposits dating to approximately 9 to 10 million years ago, Auranopithecus was a large ape, significantly larger than Dryopithecus, with estimates placing adult males at 50 to 70 kilograms, roughly comparable to a female gorilla. The face of Auranopithecus is, in the fossil record, more robust than Dryopithecus, a heavier brow ridge, a broader, flatter face, the specific jaw architecture of an animal that processed tough, fibrous vegetation. Some researchers have proposed that Auranopithecus, or an ancestor closely related to it, was the direct ancestor of the gorilla lineage, that modern gorillas trace their origin not to Africa but to the Mediterranean region of southern Europe and western Asia, and that their ancestors migrated south into Africa as the European climate cooled and the forests retreated. This interpretation remains contested. But the specific anatomical similarities between Auranopithecus and modern gorillas, the brow ridge architecture, the jaw proportions, the molar surface morphology, are real, documented, and difficult to explain by coincidence alone. And then there is Gigantopithecus. Not European, its range was South and East Asia, but impossible to omit from any honest account of what the primate world looked like before humans arrived. Because Gigantopithecus blacki, which lived in southern China and Southeast Asia and survived until as recently as 100,000 years ago, within the period when Homo sapiens already existed, was the largest primate that has ever lived. By a significant margin. Based on jaw and tooth fossil evidence, the only fossil evidence that survives, Gigantopithecus, like all great apes, had bones that did not preserve well. Researchers estimate an adult male Gigantopithecus stood between 2.7 and 3 meters tall and weighed between 200 and 300 kilograms. A gorilla-like posture, a face dominated by an enormous jaw built for processing bamboo and tough plant material, and a size that made it larger than any living primate by a factor of approximately 3. It was alive when your direct ancestors were alive. It was alive when Homo erectus was walking through its territory in China. We are not certain what it looked like because we do not have a skull. We have jaw fragments and hundreds of isolated teeth. The rest is reconstruction. The rest is educated inference from the proportions of the bones we have. The image in your head right now is partly scientific and partly imagination. Which is its own unsettling fact about a creature this large and this recent. Now back to the European story, because the question of what ended the European primate dynasty is as important as the dynasty itself, and the answer is one of the most consequential ecological events in the history of this planet. Beginning approximately 7 to 8 million years ago, the global climate began a significant cooling trend. The Miocene climatic optimum, the warm, humid period that had sustained the rich forests of Europe and allowed the extraordinary diversity of European apes, was ending. Europe's forests began to contract. The subtropical and warm temperate forest that had covered most of the continent began retreating southward and eastward. In its place, drier, more seasonal, more open habitats, grasslands, savannas, woodland mosaics, that were simply not the environment that the forest-adapted European apes had spent millions of years evolving for. The European ape diversity collapsed. One genus after another disappeared from the fossil record. The migration routes back to Africa, which some lineages appear to have taken, potentially carrying with them the anatomical features that would eventually be expressed in the human clade, closed as the climate shifted. The window of exchange between Europe and Africa, which had allowed apes to move in both directions for millions of years, narrowed and eventually closed. And then, approximately 5 million years ago, something happened that geologists call the Messinian salinity crisis, one of the strangest events in the geological record of the Mediterranean region. The tectonic collision of Africa and Europe closed the connection between the Atlantic Ocean and the Mediterranean Sea. The Mediterranean, cut off from the Atlantic's replenishment, began to evaporate. Over approximately 600,000 years, it partially or completely dried out. The basin that is now a sea was, during this period, a vast, hot, arid depression, in places as much as 5 kilometers below the surrounding land surface, with hypersaline lakes and salt flats occupying the deepest zones. When the Atlantic reconnected to the Mediterranean approximately 5.3 million years ago, the Zanclean flood, one of the most dramatic geological events in the last 10 million years, refilled the Mediterranean basin in what researchers estimate was a period of somewhere between months and a few thousand years. By this point, the European ape story was essentially over. The final primate populations that had survived the cooling of the Miocene in the refugia of southern Europe, the warm pockets of the Mediterranean coast where the forest held on, did not survive the combined pressure of climate change, habitat loss, and the ecological disruption of the Messinian event. The primates of Europe went extinct. The forests grew back in a different configuration. The landscape changed. And the continent that had been home to at least 14 genera of apes, to animals that walked upright in Bavarian forests 11.5 million years ago, to the possible ancestors of gorillas in the Aegean region, fell silent of primate life. For approximately 4 million years. And then, somewhere between 1 and 2 million years ago, a new primate arrived in Europe. Walking on 2 legs. Carrying stone tools. Making fire. Moving through a landscape that its distant relatives had shaped and occupied and abandoned long before this new species had any awareness that a primate world had existed here before it. That new primate was Homo erectus. And its descendants, approximately 300,000 years ago, became us. We did not arrive in Europe as the first primates. We arrived as the latest. We arrived in a landscape with a primate history that stretched back 30 million years before us. And the most disturbing question in the entire story is this: the Miocene apes of Europe, Dryopithecus in the oak forests of Spain, Danuvius walking upright in Bavaria, Auranopithecus with its gorilla-like jaw in the sun of Greece, what did they think? Not in human terms. Not in language. But what was the quality of their inner world? What did the amber eyes behind that almost familiar face see when they looked down from the trees at something approaching? We will never know. We have teeth and jaw fragments and isolated femora and the specific curve of a knee joint that researchers argue about in the pages of Nature. We do not have their thoughts. We do not have their social structures in any detail. We do not have their calls or their bonds or their fears. We have their bones. In the rock of a Europe that was theirs for 30 million years and is now ours for 300,000. And the specific cognitive dissonance of that ratio, the 30 million years to the 300,000, is the most important psychological fact in this entire story. Every time you walk through a European forest, through the oak woods of Spain or the beech forests of Germany or the ancient remnant forests of Britain, you are walking through a landscape that was home to primates for tens of millions of years before you existed. The forest does not remember them. But the bones in the rock do. The amber eyes watching from the branches are gone now. But they were there. For 30 million years. Looking down at a world that was, for every single one of those years, theirs. If that landed somewhere, drop a comment. Tell me which fact in this story you will still be thinking about tomorrow. And tell me where in the world you are watching this from. Because this channel exists for people who want to understand not just what we are, but what was here before us, and what it means that we are the ones who survived. See you in the next one.